When we think about expanded notation, we're thinking about representing our representing what each digit in its place value really means. So let's say, for example, I have 0.1 for for 1/10. Okay, for my expanded notation, I'm going to write there's 0 ones plus 1/10. 1/10 is shown as 0.1. 0 plus 0.1 is equal to 0.1. That's how I would expand 0.1. Next, what if I have something like 2.1? This is 2 and 1/10. To represent this in expanded notation, I'm going to show what 2 ones mean. 2 ones means 2, and then I'm going to add what comes next. I'm going to show what 1/10 means. 1/10 means 0.1. So 2 and 1/10 is equal to 2 plus 0.1. That's the expanded notation for 2.1. What if we were looking at 2.12? This is 2 and 12/100ths. I would need to show in expanded notation what the 2 in my ones means, what the 1 in my tenths mean, and what the 2 in my hundredths mean. So I'm going to show that now. I have 2 ones, which means 2. Then I'm going to add 1/10. 1/10 is shown as 0.1. Next, I'm going to add 2 hundredths. 2 hundredths is shown as 0.02. So my expanded notation for 2 and 12/100ths is 2 plus 0.1 plus 0.02. Lastly, let's say I wanted to show expanded notation of a decimal number in the thousandths. Well, I need to show what the 2 in my ones mean, and I need to show what my 1 in my tenths mean. I need to show what my 2 in my hundredths mean, and I need to show what my 6 in the thousandths mean. I'm going to write that 2 ones is the same as 2. Then I'm going to add 1/10, which looks like 0.1. I'm going to add 2 hundredths, which looks like 0.02. And then I'm going to add 6 thousandths, which looks like 0.006. So 2 and 126 thousandths in expanded notation is 2 plus 0.1 plus 0.02 plus 0.006. That's how you do expanded notation for decimal numbers up to the thousandths.